AQUABIZ, all the best knowledge for aquatic system.
Here comes literally some of the trials that we do in Latin America. Let's start with the first one in Mexico, in Campeche, Mexico. It's not going, okay, got it. Again, this is the first one built in Latin America. Again, I told you in the beginning that we found this halfway built without our guidance, our advice. This was built with some problems. For example, this area here, from here is too small. The location of the raceways compared with the baffle is not the correct one. So we couldn't do much about it. It's already there. No, well, let's deal with it. Basically, the feeding regime and the 40% soy inclusion, feeding 4 times a day. So the experience was very well accepted. And here is some important information about production. If you notice, for example, the final biomass is not much that we produce in this first trial. But how much you produce is not as important as this number here. The return of the investment of the average on the raceways compared with the traditional ponds. Even though you produce small quantities, it's still being better profits than the regular ponds. We have plenty of information in this farm that they give us a 38.6% of return in investment compared with 22.8 in the regular traditional ponds. Now, if we have the financial statement, check the electric power is somewhere around 11% of the operation cost. This answer, is some of the answers that the people in Latin America were questioning. If I run the blower 24/7, how much electricity I have to pay? Yeah, you pay a little more if you like, but if your return on investment is higher, it covers the cost. No problem. And at the end of the picture, we analyze it. Of course, to do this, you have to go to the accounting system and do a lot of work in the accounting system. But overall, this is what we have there. It's a nice, very good experience. But if something happened in this farm that I want to share it with you because it's important if you are to adopt this technology. It's very important. The farm is closed today. The manager that contacted us and he went to our conference in Mexico and went to do this, convinced that this technology is good, he was fired. And we don't have absolutely no idea why the owner fired him. And the new manager was a lab biologist. And as a lab biologist put it into a farm situation, that was kind of hard to pick up the overall picture what you got. And just dealing with the pond, it was a lot of work. And they didn't put attention to the IPRS and then COVID come on board. You guys know for a fact that COVID put the business down hard. And that was a problem. That was a problem because the person in charge didn't put attention to the IPRS, and they shouldn't put, because you got better profits than the traditional ponds, but it didn't. I'm sorry to say it, but in the future, this is a good example of a failure. You as an owner and you as a manager have to be in the same synchronization. If one of those two are not in sync, these do not work. Sorry, these don't work. We have not just this example. We have in US, in the catfish farmers, we also have the same example. The owner says, yeah, we do it, but the managers don't like it. And it just don't go. It never progress because they don't put attention to it. So, let's go to another example. We're going in Chetumal in Mexico, south of Cancun. You may hear about Cancun in Mexico, a very nice place, beautiful place. So, this place, it was abandoned farm. This gentleman get this farm and start building those ponds, recovering those ponds. Almost 1 hectare ponds. They got about 10 of them literally there. And this gentleman is a civil engineer. Listen carefully, civil engineer. But he never worked as a civil engineer. He worked as aquaculture guy all his life. Very smart guy. And he called me, Esau, I just don't want to do it in concrete. I want to do it in pond liner. What about that? Well, we never had that experience before. I said, well, come back to my farm and please evaluate with me several prototypes. And he built small pieces of wall dry, right there in the yard. And we evaluated, well, this one, well, we choose this one, we better, and they start building it. Basically, like a fence. Of course, we make some mistakes. You will see it in a minute. For example, here, you cannot walk in between the raceways, neither on the side. That was a mistake, but that was the first one. But it was very economically feasible, but it's still highly productive. Highly productive. Let's see what we got. This is already in operation. Water is running, it's smooth, beautiful. Put the fish in there, it's working perfectly fine. Boom, production. Look at this, railway number 1, almost 12 tons. And in 2, 15.5 tons in the first harvest. Oh, put attention. He built it a very economical way with pond liner, high harvest. And then we got electric power, very low. When you have those three combined, power low, investment low, and high production, you get this. Return on investment very high. Now, let me ask you guys a question. Why the power is low here? And the blowers are running 24/7. Mexico give you, because it's an agriculture business, they give you subsidized electric power. So that's very good. And then we have Another in Mexico, Tupes. Tupes went to invest, high investment, and he have a pond with 3.39 hectare ponds that was literally empty. And the owner came to visit China, visit Vietnam and other countries to see how it is, how we can do this. The depth, 2.95 meters of water, giving a total of 108,265 cubic meters of water, and volume of culture area in 10 of those raceways. Look here. He built the raceways a little bit deeper. We told him, don't do it that way, just do it. But eventually, it's his farm, it's his money, and he wants to do it that way. We advise up to a point. So, always they try to keep this relationship. One raceway for every 10,000 cubic meters of water. What we have there, he stocked 38,000 fish in only 4 raceways out of the 10. Now, we evaluate every 15 days growth, and when it went close to 550, then it's time to harvest. We run some statistical regressions to see how it's doing in terms of typical, but that's no problem. Is any of you guys hear about the condition factor in fish? No? None of you guys? Again, the same people. Okay, the condition factor in fish, and I understand that this is catfish and we working in tilapia, but this is only to show you what is the principle of the condition factor. Basically, what it says is a fish this length with this weight, you have to be very much at this weight evaluated. But if it's this length with this weight, something happened to this fish, and this is exactly the performance here. What happened there that the Fulton condition factor went down here? This is when you understand the Fulton condition factor, it's an indicator of health in the fish. If something goes wrong in any condition that you have, water quality, feed, or health, it will show in the condition factor. Now, what happened in Tupes is that they fill the pond and they stock the fish almost immediately. But the temperature of the water was about 23 degrees. Listen careful, 23 degrees. There is so many things happen there. Many. Immediately when the fish start growing, the ammonia start going up. Ammonia, in this case, they never went no more than 3 ppm of ammonia. And when it reached 6, the owner called me, Esau, my fish will die tomorrow or today. No, I said, no. You go home and sleep tight. No problem. No, but explain why it will be okay. Well, a very simple factor. The concentration of ammonia, the pH and the temperature give you the unionized ammonia, which is toxic to fish. The ammonia, not much. I have examples of fish going up to 10, 11 in ammonia that don't bother the fish too much. But the the unionized ammonia is a problem. And when you have high ammonia, high pH, and high temperature, the percent of unionized ammonia, it could be a problem. But in this case, I make an evaluation of those 3 factors and how much unionized ammonia they have. I never get to the toxic level. I said, just go home and sleep tight. The only thing you have to do is lower down the feed intake. The feed intake. And then it show up right here. I said lower down the feed intake. They just literally quit feeding. Totally feeding, no feed. And of course it showed in the condition factor. Boom. When they start feeding again, the condition factor start coming back up. So condition factor is a good indicator. When you really understand that, it's a good indicator, better than anything else. Here we have, this is tupes with an average of 16.5 metric tons of tilapia. It's amazing. It's amazing. So, unfortunately, tupes do not want to share the financial statements. They said, no, I do whatever you want to, but I don't want to share economic factors. So, that's fine. And the important factor here is that we have 1, 2, 3, 4 raceways, and we have 15 and a half, 18, 16 and a half, 15, almost 16, with an average of 16.5 metric tons of tilapia per raceway. Per raceway. If you have 10 of those in a pond of 3.39 hectares, you get a nice production. This pond produces the same as the whole farm combined. Use one pond. So today they literally increase and standardize the production about 18 tons per unit. And they're in operation, they're very happy about it. And they learn how to handle the situation here. Once the temperature, remember, this trial was run in December, January, and February. And at that latitude, the winter, remember, December, January is winter time in the United States, and the cold weather comes down to Mexico about that time. So the Nitrobacter and Nitrosomonas do not survive well at lower temperatures. That's why the ammonia went up. And the ammonia went up, they were concerned about the unionized ammonia. So all those combinations took place. So anyway, the production a year can be very close using this pond and 140 tons per hectare. That's very good. So, harvesting IPRS. This one, you got the fish already ready to go. Can you play this? This one. You literally, now look at the people that is harvesting. Now, are you guys harvest tilapia before? No fun, eh? No fun at all. Now, those people up there, they call my name every time they harvest here. Say, thank you, Esau. You're good. Because they don't even touch the water up to that point. It's a lot easier. The fish is already caught. They crowd them up to this point. But look at the device they built in Colombia. Almost everyone have that, what do you call it? What is the word you use? Look. Yeah. Okay. And then go straight to the truck. Straight to the truck. And go to the market. Bingo, we got it. But you notice there is a scale there. And the owner, this is Fabio, the owner used to record the weight. Go to the market, go to the processing plant. Bingo. What we achieve here, we got better production, we keep water for years, we extract the fecal material out of the water, which literally increase the carrying capacity of the water. That's the overall picture. So, Look at this one. Colombians are very particular in terms of, you may see some of the videos of fish collecting in other countries, especially in Honduras. They don't care, they like the red tilapia, but the Honduras, they have fish with the spots. Colombia, they don't like the fish with the spots. They like a clean red. And that's what you see here. There is no fish with the spots. They're very particular in that sense. So, let's go to Honduras. In Honduras, we got a small little ones, IPRS raceways, but the small. These small ones are the ones that we use in Auburn University for research. They're incredible good for research. Think about that. Traditional research in aquaculture, you have to have several ponds. Let's say you want to run replicas of 3 or replicas of 4 in 3 treatments. You need 12, 16 or so ponds. But the ponds are not always the same. We assume that they're the same, but they're not always the same. In here, it's the same water, the same parameters. The only variable is the one that you study. It's amazing. So, but why those guys in Honduras are adopting the small ones? Oh, interesting question. Because they don't want to harvest a big raceway and stress the rest of the fish, because the market is for small quantities. It's a local market. It's a small city, and they want to sell small quantities. I said, no, we don't want a big one. We want a small one, and we want to harvest the whole raceway all at once, that we don't stress the rest of the fish. Fine, perfect. So, in this case, one pond with 4,225 cubic meters of water, a little deeper than we wish, 3.7 with this volume in a total of use raceway about 1.86% of the total volume of water. This project is located 1,200 meters over the sea level, a little higher than we wish to have, but anyway, that's what they got. And out of the 20, we choose only 12 and 6 for each treatment. 2 commercial diets, again, totally different than the previous research that we have in the fish Wesley structure. And with totally commercial diets. And we stock initial weight, 37 and 39 grams fish in this setting right there. Stocking very much principle of aquaculture. A small harvest size, bigger number of fish, period. So, big numbers, stocking here, no problem. We also monitor every 15 days to get to the point where we get 350 grams fish. Perfect. Now, what we have? This is red tilapia. Red tilapia means it grows slower and it takes longer to harvest. Is that correct? Do you agree with that? Everybody on board? So, it took 117 days. And grams per day, they never ever reach this much before. They usually go from 1 to 1.5 the most in Honduras on growing every day. It takes way longer to achieve this weight. So when they see that, I say, well, this is very good. This is very good. So the condition factor don't change much between red tilapia and the regular tilapia, and the survival rate, that's very good in there. Now, if I show you this data on production results, harvesting average in diet A, 1,245 and in diet B, 1,273. It shows you this data. What conclusion can you get? Which is the best? The hypothesis will be, what is the best diet to produce fish in Honduras? Is diet A or diet B? So, what do you think based on this data? Which one is better? Anyone? Don't be afraid to say it. Both of them are commercial diets. One is cheaper, one is more expensive. Now, put attention to the FCR. FCR is very important here. Look at this, 1.36, 146. That means 0.1 difference, okay? When we do the analysis, the economical analysis, tell me now which diet is better. Huh? You see? You see the profits in diet A and the profits in diet B. Even though with the production results, diet B look like it produces more fish, correct? But not always the producing more fish will be more profitable. That's the conclusion that we have out of this study. So, but in the overall, either one, even diet A or diet B, it made very good return on investment. I mean, it's over 40. That's very good in my opinion. Consider the fact that traditional ponds are somewhere around 20 to 22. So, if you want to read the whole article, it's published in Aquaculture magazine, March 22. I invite you to visit, read more about it. Okay? So, let's go to Colombia. Another place, very exciting place in Colombia. Those are some of the small details that we want to share with you guys here. This farm is managed by a lady, a very smart lady, that we have been visiting for years before they take the decision to adopt this technology. And the lady was very convinced that this is the way to go. So, but the owner said, no, I'm not convinced yet. So, when we present data from Mexico, and say, well, this is the data. I mean, you guys, it's a good data. They took the chance. Okay, we want to build one pond to see how we go. But before we go into that, let's analyze the situation of this lake, because this is the supply water for this farm. It's a high alkalinity, more than 400 milligrams per liter. That's very good. Very good water. So, salinity between 0.6 to 1 ppt. But this in an eutrophic lake. Ooh, we got problems there. It's highly eutrophic lake. And also, it's an endemic low dissolved oxygen concentration. That's a challenge to produce fish in there. Highly challenged. That means the whole production of this farm is low compared to the average, the national average in Colombia. But the lady is very smart. He deals with that and produce fish. So, we set a study to compare vaccinated fish and not vaccinated fish. That means they have a mortalities, or let's call it the other way. They have a survival rate about 60% with fish not vaccinated, and they have a problem because the conditions are really, really bad. And the survival rate was very low, 60%. It's a challenge. And they say, well, let's do an experiment with raceways with vaccinated fish. Let's see how you go. So they give us a pond with 1.14 hectares with a 15.9 cubic meters of water with 3 cells. So if this work, we will probably do the whole farm with IPRS. And this is harvesting the IPRS manual harvest. Okay. As you see, also is not a great amount of biomass harvesting in there. That's 9 tons, almost 10 tons there, with a final harvest of 28, almost 29 tons in that particular pond. So remember, we have a survival of only 60% of traditional ponds not vaccinated, and we elevate the survival rate to 84, 85, somewhere in that neighborhood, which is a lot better, a lot better. So when we analyze the cost, we have also very close to 10 in the electrical power, which is one of the highest concern everywhere that we present this technology. So, and this is by far the most precise economic evaluation of the IPRS so far. And we come back to the return on investment in IPRS of 30%, and traditional was 16%. Ooh. When the owner wasn't convinced, remember, the owner wasn't convinced totally that this technology was good. When the owner did this evaluation with his accounting office and present this report to the board of directors, said, why you didn't adopt this technology before? Esau has been coming here for 3 or 4 years. Well, so another question that the people ask is, even though we have been showing you IPRS confronted to traditional ponds, we did another study with Botero Fish Farm, which is 9 farms in one owner. They give me a lot of data, and we evaluate the high densities stocking with low density stockings compared to IPRS. Again, this one was the first one in that particular farm. They make also as a trial to see if it works in pond liner. Low investment again, but it works really well. So you want to read the whole article, I invite you to visit World Aquaculture magazine, June 23, last year. So, and this is the results. I put some statistics in there if you wanna evaluate it that way. But basically, traditional high, traditional low at 5.6 and 3.9. That's the compared to the IPRS. There's an asterisk in there. IPRS do not measure in fish per square meters, but in order to compare to, we have to make those numbers. IPRS goes for cubic meters, okay? But anyway, the high densities produce very low kilograms per harvest, 14.5, 14.6 tons per harvest, per hectare. in low density, the production goes way higher, 26.5 tons per cycle per hectare. But let's see what happened with IPRS. It went to almost 37 tons. Those are the questions that the people ask all the time. Why should I adapt it? If I'm producing my fish well in traditional ponds? Well, here are some answers. And you see the evaluation on return on investment. If you produce more, the cost is less. So,
Can you go back? What are the reasons for high mortality? Go back.
oh, good question. Excellent question. Excellent question. Hold on a second. Excellent question. Yeah, thank you. When we run this particular experiment trial, the original design was to evaluate, again, vaccinated fish and not vaccinated fish. But that was the first time that farm vaccinated fish and didn't know exactly what protocol do in the vaccination. So they start very early in the morning, harvesting the fingerlings. They start injecting the vaccine. Look at the time, very early in the morning. Vaccinate fish, take it out of the water. It has to be anesthetized, okay? Take it out of the water, put it in the truck, drive 3 hours to the farm to stock it here. By the time we get there, most of the fish die. So they didn't know exactly how much they got. But the experiment was absolutely torn down because they put no vaccinated fish on top of the ones that are vaccinated. And that was, they didn't know how much mortality they have. So when we harvest, the actual protocol of the experiment was totally broken. So they just put more fish in there. Because the farm don't wait for you to do research. They want production. They don't care. So when we harvest, we phase out to be 61.8 survival rate, which is low. Even though low survival, we are still producing more fish. Excellent question. Thank you for your observation. So, and as you see, there is a comparison, a statistic comparison in there, but I don't go into those details too much. So, other farms in Colombia, building some more. One thing that's very particular in Colombia is that once they see this is working, they came back and said, well, I want to adopt this, but they start from buying the land and plan from zero with civil engineers, all the contour lines and all these locations to build farms from zero. Now, that means that we have the chance to put all the USSEC specs into those farms. Very well done, absolutely very well done. We have farms that one pond, 12 units, 14 units, 16 units, huge ponds. And there are, let me show you this. They planned it this way. Some of them 4 units, some of them 3 units, and so forth. Let me see if I can have some more. For example, this one. This is the last one I visit. But this is one pond only. There is way more ponds this way, and they want to build all of them with IPRS. Colombians are very interesting people. They found a market they usually sell fish to United States in Miami, Atlanta, Washington, D.C., New York, all the East Coast of the United States. But one guy that was literally looking for market found market in San Diego and Los Angeles, in the west side of the United States, and Mexico City. Those three markets, it's incredible. You don't feel them. I don't know if you guys have the chance to visit Los Angeles, for example. It's incredible big city. They take any fish, any quantity of fish. It don't matter. You don't feel the market. So, during COVID, the hatchery guys didn't go to work, and they literally run out of fish, fingerling fish, because they found this new market. They have to call those guys and say they force them to come back and they start producing fish, take care of the brooders, and that was it. So, overall picture, a summary of what happened in Latin America. All of this is Tilapia nilotica, this is red tilapia, and this is catfish in Auburn University. So, in overall, what we could collect information about the return on the investment, they give us about 39%. But if you get 30%, it's good. 30% is good. In red tilapia, with the experience up there, this red tilapia got better price, get the market price. So, in catfish also when this is very good. Usually catfish don't get that much. So, as a take-home conclusions of this presentation, IPRS, you get better control of biometrics. Easy to have samples, easy to control survival, easy to control mortalities, easy to treat if the fishes are sick. Usually, if you have a traditional pond, if you got sick fish, you have to treat the whole pond. Here is not. You treat only the cell that is very small volume of water, for example. Then you have produced more biomass per area. There's no question about it. You have higher return on investment for a hectare. Water consumption is less than traditional ponds. Bird predation is controlled. Is environmental friendly. This is the most important thing here. Once you take the fish Wesley out of the water, out of the environment, aquatic environment, this is huge. It's huge. So, this gave me a better quality, water quality for the fish. We get the pollutants out of the water as much as we can. So, best result with fish is fed with American soybean inclusion. Okay? You got the book as a reference. Read it, be involved, and when you decided to do something, let us know. We can help you. This is my take. This is my personal statement.